So, good day. Ang topic ko ngayon is tungkol sa special types of transformers, in which ang discuss ko is dalawang types ng dalawang type ng instrument transformer, which is the current transformer and the potential transformer. And i-discuss ko rin yung calculation ng errors ng dalawa, which is their ratio error and the phase angle error. So, ito, current transformers. Ang i-discuss ko ngayon sa current transformers is ito na yung lineup, basic concept. Next is the parameters of current transformer. Next is the calculation of errors with phasor diagram, ratio, and phase. Tsaka lastly, the sample problem. So punta muna tayo sa basic concept. So ang current transformer is a current measuring device used to safely produce a low-level current that accurately represents higher current level for the purpose of metering or protection. So, basically, ang current transformer ay isang instrument transformer na nag-i-step down ng high value ng current punta sa low value ng current para maging suitable siya for measurement devices. So, naka-dyan yung ammeter. So, ayan. So, sa naman, sa construction naman niya is dyan parang ngayon lang din yung winding na may kunting kunting turns, yun na yung primary winding niya, which is connected sa main circuit. Tsaka yung secondary winding naman, yun yung pinakamaraming winding na nakakonect sa tawag doon, sa ammeter. So next. So ito yung symbol ng current of transformer. The symbol represents terminal P1 and P2 and the ratio niya is 100/1. Saka yung primer circuit naman kung saan yung CT is connected is shown nagka-carry siya ng current of 200 amperes. Yung secondary current naman ng current transformer will be 200/100, which is equals 2 amperes. So we have the following parameters of current transformers. Meron tayong tatlo. So to discuss, ang current transformer is defined by its current turn ratio, accuracy class, accuracy limit factor, and instrument safety factor. So dito sa natin discussion, ang pagpupokusan lang natin is yung accuracy class, in which i-determine natin yung mga phase angle error and ratio error ng current transformer. So we have three parameters: turn ratio, transformation ratio, and the burden. Yung turn ratio, defined as the ratio of number of secondary winding turns to number of primary winding turn. It is often denoted by N, and given as N is equal to number of secondary windings, or NF, and over number of primary winding, or NP. Yung turn ratio, naman, denote siya sa N, or either A, yung ibang libro is A. So next is transformation ratio, defined as the ratio of primary winding current to secondary winding current. It is denoted by R. So R is equals to primary winding current and the secondary winding current. Next naman is burden. Can be defined as the volt ampere of connected load across the terminals for secondary winding of CT, or the current transformer. So ito na yung transformation ratio niya. Dito yung na-derive sa may phasor diagram ng current transformer. Sa lang yan, ang ginamit lang na method na pag-derive niyan is yung right triangle, parallelogram method, tsaka mga cosine laws. May sasanda na akong niyan, derivation. Medyo mahaba yung derivation yan eh. So next, basta nyo na ito na yung formula. Transformation ratio, R is equals to N plus I naught over IS times sine. Yung angle niya is alpha plus delta. So that is transformation ratio. Saan yung mga following variables natin is denoted as yung IS as the secondary current, IP is the primary current, N or A as the turns ratio, IM as the magnetizing component of I0 or the excitation current, IE as the core loss component of the excitation current, ES as the secondary induced EMF, phi as the main flux, and lastly the I naught, which is the excitation current. So based dun sa mga equations or mga formulas na nandun, may mga following points lang tayo na dapat tandaan. Yung transformation ratio ay dapat hindi equal sa current transformer turn ratio. Yung transformation ratio naman is nakadepende sa excitation current and dun sa angle. Next, for transformation ratio to be equal to turn ratio, yung alpha tsaka yung delta must be equal to yung angle alpha equals to angle alpha tsaka yung delta must be both equal to 0. This means that there should not be any core loss in the current transformer, and burden should be purely resistive, or unity or power factor must be equal to 1. So ito na yung phase angle of a current transformer. Ito lang din siya na-derive sa phasor diagram na to. Saan ko na lang yung derivation, medyo mahaba eh. Ang formula is phase angle equals to 180/5 times magnetizing current cosine delta minus core loss component sine angle delta all over yung reflected secondary winding, or N turns ratio times yung secondary current, or yung NIS na yun, pwede natin siyang tawagin na reflected secondary winding, which is the unit of this phase angle must be in degrees. So ratio error of a current transformer. So ratio error is defined as the per unit deviation and transformation ratio from nominal ratio. It is expressed in percentage. So percentage ratio error is equals to nominal ratio minus actual ratio. Yung actual ratio, it can also be called as the transformation ratio. So patuloy natin, nominal ratio minus actual ratio all over actual ratio. Since yung ratio error natin is naka-percentage, multiply natin siya sa 100. And next is, since the burden of current transformer is usually resistive, meaning yung power factor niya is 1, tapos yung angle niya is 0, therefore power factor is almost unity, or unity na nga. So ayan, R is equals to N plus I naught, or excitation current sine alpha all over IS. But yung natin, yung burden natin is almost unity, meaning yung core loss component is 1. Kasi is kakaroon tayo ng transformation ratio na N plus IE all over IS. Ngayon, yung percentage ratio error naman na na-derive from the turns ratio, and dito rin is equals to reflected secondary winding, or IP reflected secondary winding minus IP all over IP times 100. Ito din siya na-derive sa phasor diagram na ito. And again, saan ko na lang yung derivation sa PDF file para hindi mapahabang masyado yung discussion natin. So, ulitin natin yung mga following variable: secondary current, IS, IP, primary current, and turns ratio, or A sa ibang libro, IM, magnetizing component of excitation current, IE, or the core loss component of I naught, or excitation current, ES as the secondary induced EMF, phi as the main flux, I naught as the excitation current. So next is the phase angle error of current transformer. So the phase angle error is ang formula lang talaga dito is magnetizing current all over reflected secondary winding current. Pero since ang hinihingi dito is naka-degree, lalagay na natin yung 180/pi para hindi na tayo mahirapan. Included na dun sa formula yung 180/pi para diretso na makuha natin yung degree value ng phase angle error. So next. So we have this sample problem ng current transformer. So there are 300 turns in secondary of a current transformer with single turn primary. A resistive load of 3 ohm at 3 ampere is connected with the secondary at a frequency of 50 Hz. 8080 is the magnetizing MMF required to set up the flux in the core. So the magnetic core has a cross-sectional area of 5 centimeters squared, or 5 times 10 is to negative 4 meters squared. And ang hinahanap dito is find the maximum flux density in the core, neglecting the iron and copper losses and the ratio error and phase angle of the current, or phase angle error of the current transformer. So proceed tayo. So we have the following givens: secondary turns 300, primary turn 1, yung secondary impedance 3 ohms, secondary current 3 amps, MMF natin is 80, frequency is 50 Hz, and the area is 5 centimeters squared. So ito na yung solution natin. Yung turns ratio natin, formula is NS over NP, which is 300 over 1. Turns ratio is equals to 300. Tapos kung kukunin naman natin yung reflected secondary winding current, that is turn ratio times secondary current, equals to 300 times 3, which is equals to 900 amperes. Ngayon, diretso na tayo sa problem. Ang first na hinahanap is maximum flux density. Ngayon, ang formula ng max flux density based from our subject na electromagnetics, which is V all over A. Yan yung formula ng maximum flux ng flux density. Ngayon, ang hanapin natin dito is yung phi. Ngayon, makukuha natin yung phi sa induced EMF equation ng induced EMF equation of a transformer. Dito sa So, kunin natin yung sa may una muna, yung secondary induced EMF. So, ang voltage sa by Ohm's law, makuha natin yung induced EMF by current tapos yung resistance or the impedance. ES is equal to IS, secondary current times secondary impedance, which is 3 times 3, which will be equivalent to 9 volts. Ngayon, sa isa naman, para makuha natin yung magnetizing flux, we will be using the induced EMF equation of a transformer, which is equals to ES equals to 4.44 times frequency times magnetizing flux times the secondary turn. Ngayon, since ang hinahanap naman is yung magnetizing flux, ang gagawin natin dito is ma-modify lang, i-divide natin both sides by 4.44 times 4.44 F tsaka secondary turns. So we will have the following expression. Magnetizing dito, flux will be equivalent to secondary induced EMF all over 4.44 times frequency times secondary turns ratio. Yung secondary induced EMF natin is 9 volts all over yung constant na 4.44. Yung frequency natin is 50 Hz, tsaka yung secondary turns natin is 300. So, putting that in a calculator or a scientific calculator will result to 0.135 milliweber. Ngayon, may nakuha na tayong magnetizing flux. Para makuha natin yung maximum flux density, dyan na yung pinakita kong formula. Substitute natin yung value ng magnetizing flux dito sa maximum flux density all over yung given na area, which is the 5 cm squared or the 5 times 10 raised to negative 4 meters squared. And substituting all the values, we will get 0.27 Weber all over meter squared. So, yun na yung maximum flux density natin. Kaya tayo sa part 1. Sunod is the ratio error. So, sa ratio error naman, since yung load naman is purely resistive, ito lang muna. Ang natin, MMF natin is 80, and we have the IMNP. Ngayon, para makuha natin yung magnetizing current, substitute lang natin yung value ng sa primary turns, which is equals to 1. So we will have IM is equals to 80. So, since ang load naman natin is purely resistive, meaning ang delta is equals to 0, tapos yung core loss, yung the loss component of no load current is to be neglected. Therefore, ang core loss component natin is core loss component current is equals to 0. Hence, yung alpha natin magiging 0. Therefore, yung excitation current will be equal to magnetizing current. So, ito yung formula natin. Yung formula na to, na-derive lang to sa cosine law of the phasor diagram from the phasor diagram of current transformers by using the parallelogram method of vector diagrams. So, anyways, nandun lang din yung derivation nito. So, IP is equals to, or dito na lang para mas madali. IP is equals to square root of Ni, or the reflected secondary winding current squared plus excitation current squared plus 2 reflected secondary winding current times excitation current times cosine with the angle of 90 minus alpha minus delta. Ngayon, since yung natin, yung IE natin or core loss component natin is 0, or yung IO natin is 0. Therefore, hindi pala, wait lang. Yung IP ay yung natin, mali pala. So, sorry, ulit natin. Yung formula is IP is equals to square root of NIS squared plus I naught squared plus 2N IS plus I times I naught cosine angle 90 minus delta minus alpha. Ngayon, since yung yung alpha natin ay magiging 0, because yung no load current is neglected, saka yung delta natin is magiging 0 din kasi yung load natin is purely resistive or in unity. Ang lalabasan nito is magiging cosine 90 na lang. Ngayon, cosine 90 is equals to 0 kasi ang cosine is nakadepende sa x coordinate, hindi sa y coordinate. Therefore, itong cosine nito magiging 0 to. Mag-multiply dito sa 2 times reflected secondary winding times excitation current. Since naka-multiply siya or naka-product, cancel out lang siya. So, we were left with this following expression, following variables. The primary current is equals to NIS squared plus I naught squared. So, substituting the values, we get square root of 300 times 3 squared plus 80 squared, square root siya, will be equivalent to 903.54 amperes. Tapos, ko lang yung i-state ko lang yung isang given na ang secondary current natin is 3 amperes. Ngayon, ang required dito sa part 2 na to is ratio error. Para makuha natin yung ratio error, gamitin natin yung formula na naka-state kanina. So, ratio error is equals to NIS minus IP all over P times 100. Ngayon, we have this formula, written na. Ngayon, to get the ratio error, multiply lang natin yung 3 sa 300 minus 903.54 all over 903.54 times 100. And we'll be having a ratio error of negative 0.39%. So, yung sa part 3 naman niya, hinahanap is yung phase angle. Sa phase angle naman, we have the since yung sa part 2 na discuss ko na ang I naught is equals to IM kasi yung no load current is to be neglected. Since is to be neglected, yung no load current is to be neglected. Hence yung angle alpha niya is equal to 0. Therefore, I naught is excitation current is equals to magnetizing current, which is equals to 80 amperes. Ngayon, to get the phase angle or the phase angle error, we'll be having this 180 over pi dito, ulitin ko lang, dito talaga to kasama sa formula. Ang formula lang talaga natin is magnetizing current all over reflected secondary winding. Nilagay lang natin itong 180/5 para makancel yung regions. Kasi kung hindi natin kinancel yung regions, hindi magiging we will not be able to use this space angle kasi naka-region siya. Ang required na hinahanap is naka-degrees. So ayan, substituting the following values. Yung I naught is equals to IM, or excitation current equals to magnetizing current, which is 80 amps, all over yung reflected secondary winding, which is 3 times 300, will result to 5.09 degrees.